Hello, 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 and welcome back. We're on questions 9 through 12 of the 2016 midterm. Question number 9, simplify tan cosine inverse of x. Okay, so this one's a little more involved, but it's still a SOHCAHTOA question. We've done a couple of these. Okay, first thing I do is I always let theta equal the inside function. It breaks it down into two parts. Really what I'm looking for now is just tan of theta. If I apply cosine to both sides, in order to cancel out this cos to the minus 1, well, they cancel and I'm just left with x. Cos theta is equal to x. A better way to write it is x over 1. Now we use SOHCAHTOA. Remember, cosine is adjacent over hypotenuse, so if we put an x here and a 1 here, I can now solve for the other side using a little bit of the Pythagorean theorem. 1 squared minus x squared, and you square root it, you'll get this side. And tan is opposite over adjacent, so we'll get root 1 minus x squared, the opposite side, to our theta, over our adjacent side x. And if we take a look, that's answer A. So I move right along to question 10. All right, the limit as x approaches 0 of 3x minus 1 in absolute value minus 3x plus 1 in absolute value over x is equal to. All right, now absolute values are a bit tricky. A lot of people forget they are piecewise functions. So what I'm going to do is I'm actually going to do the two-sided limit here. Okay? We want to avoid the urge to plug in 0, because you'll plug in a 0 on the bottom and it just won't work. Now, 3x minus 1 looks differently depending on the x values you plug in. It'll look like 3x minus 1 if that's positive or non-negative. And it'll look like 1 minus 3x, the negative of this, when 3x minus 1 is less than 0. Now we could take a little time to rearrange, bring the 1's over to the other side, divide by 3. And so you'll say when x is greater than or equal to 1/3, or when x is less than 1/3. What about our other function? 3x plus 1. Again, it looks a little different depending on what you plug in. It looks like 3x plus 1 or minus 3x plus 1, so minus 3x minus 1. And again, we can clean things up. It looks like the top, when that's greater than or equal to 0, well, bring the 1 over to the other side, divide by 3, so that looks like 3x plus 1 when x is greater than or equal to negative 1/3. And it looks like the bottom when x is less than negative 1/3. So how does this help us? Well, for our first limit, our values of x are approaching 0 from below. So as we get closer and closer to 0, we're looking at negative numbers that are getting closer and closer to 0. Negative numbers are still less than 1/3. And negative numbers that are getting close to 0 are eventually greater than or equal to negative 1/3. And this allows me to, I'll just move this off to the side, this allows me to simplify these absolute value expressions, get rid of the absolute values entirely. So 3x minus 1 turns into 1 minus 3x. 3x plus 1 turns into 3x plus 1. Doesn't change at all. All right, and then 1 minus 1, well, those guys will cancel out. Minus 3x minus another 3x will be minus 6x over x, or negative 6. Now, what happens if we approach 0 from the other side? All right, if we also get negative 6, then good, B will be the answer. If not, then we'll probably have to say none of A to D. So 3x minus 1 minus 3x plus 1 all over x. And now if we're approaching 0 from above, well, eventually the values will be less than 1/3. And the values of x will be greater than negative 1/3. I feel like we've been down this road before. All right. It's just sort of very special that this happened to work out. If we were approaching 1/3, we'd have something very different to say here, but it's actually the same story. And we end up with negative 6 again. So, yeah, B is our answer. Nothing more to it than that. All right, 11. The limit as x approaches -4 of this expression. Now, if you just try and plug in -4 on bottom, you will get a 0. You cannot divide by 0, so we have to be a bit clever. We're going to look at the top. We're going to use difference of squares, and we are going to multiply by a sneaky 1. As we so often do. Or did in class, I guess. Now, on top, these two values will multiply together. We'll get x squared plus 9. Everything else will cancel out, except we'll also have a minus, and then 5 times 5, which will be 25. We'll get x plus 4 here on the bottom, and a root x squared plus 9 plus 5 on the bottom here. 9 minus 25, x squared minus 16. Okay, and then this on the top actually factors out to x minus 4 times x plus 4 using the exact same difference of squares reasoning. So we can actually cancel one of those. Oh, whoops, what did we do here? Oh, I hit the scroll bar. We can cancel this x plus 4 here and this x plus 4 here. We'll get x minus 4 on top, root x squared plus 9 plus 5 on the bottom. And this we can plug in -4 to. So we'll get -8 on top, and then -4 squared is 16, plus 9, 25. Square root of 25 is 5. 5 plus 5 is 10. -8 over 10, better known as -4/5. All right, 12, the last question, at least for this video. The function f of x, and we've got quite the expression, is continuous everywhere except 0. You'll notice 0 is one of these boundary cases. Everywhere except 0 and 1. Another boundary case. Everywhere except 1 or nowhere. Well, it's definitely not continuous nowhere. Pick, -1. The function just looks like this. That's continuous. You're good to go. So really what we need to do is check all these sort of boundary values. The limits of 0 from both sides, the limit of 1 from both sides. So let's get cracking. So as we approach 0 from below, the function looks exactly like -2 pi e to the negative x. That's continuous, so we can just plug in. So that'll be -pi by 2. All right, how about the function at 0, from 0 to approaching 0 from above? Well, approaching 0 from above, these values of x are always going to be greater than 0. So you're going to be looking at something like this. So it'll look like arc cos, again, a continuous function, so I can just plug the 0 in, minus pi. So arc cos of 0, what value of theta can give cos of theta being equal to 0? Pi by 2. Pi by 2 minus pi is -pi by 2. Really quickly, what's f0? Just plug it in here, and it will also be -pi by 2 e to the -0, or -pi by 2. So we're definitely continuous at 0. Crosses out B and C. It's either A or D that our answer is. Okay. Really quickly, limit as x approaches 1 from below. Well, approaching 1 from below, you're going to look like arc cos. So you'll have arc cos of 1 minus pi. What value do I have to plug into cosine to get 1 out? 0. So we'll get 0 minus pi or -pi. And the limit as x approaches 1 from above of f of x, well, it'll look like x minus 1. So plug in 1 minus 1, and that'll be 0. 0 and -pi don't match, so you're not continuous at 1, and that means our answer is D. Okay, so onwards and upwards. If you'd like to, feel free to join me for questions 13 through 16.